Okay, good morning, everyone. At the time of recording this video, it is the morning of October 28th. So let's start with some bell work for today, just some review. Solve for x using either factoring or the quadratic formula. So if you want to pause the video and write these problems down, that'd be a good idea because I will have these solutions right below this. Now, the reason I give you the option to use either factoring or the quadratic formula is because it depends on your problem. The problem B, you'll see I already lined up A, B, and C because I think it'd be easier to use the quadratic formula than it would be to factor. Though that's not to say you can't do it by factoring. It just take a little while because we'd be multiplying 5 times 15 and trying to find the factors of that. On the left side, when I'm multiplying, I've got 2 times negative 12, so what multiplies to get negative 24, but adds to get 5? The numbers 3 and 8 pop into my head. Now, for those to combine and get 5, that means the 3 must be negative, for negative 3 plus 8. And we're going to hop into my slide and divide method of factoring. Well, I shouldn't say my way of slide and divide, the slide and divide method of factoring. That's definitely not something I made. N minus 3, n plus 8 is equal to 0. Divide by the lead coefficient of 2. If it divides evenly, you do so. If it does not, you slide it up to the front. N plus 4 equals 0. A much faster way of factoring as opposed to factoring by grouping. Not that factoring by grouping is incorrect. This is just a bit faster. Set both of these equal to 0. So the first one, 2n minus 3 equals 0. We would be adding 3 and dividing by 2. For the second one, we would be subtracting 4. Now, these are points. These are x-intercepts. So get used to writing them as intercepts. And there we go. Let's use yellow again today. Classic. All right. On the right side, again, you can use factoring for this. You're just 5 times 15, 75. It wouldn't take you too long to find the factors of negative 4. That's to say, this could be one with an imaginary solution, and you might realize it's unfactorable. That is when you have to use the quadratic formula. And that's the bonus of the quadratic formula. You will always get an answer. With factoring, your results have to be real numbers. So keep that in mind. Let's see here. X equals negative b. I feel like whenever I do these, b is already negative. Plus or minus the root b squared minus 4 times a times c all over 2a. Okay. Negative 4 squared is 16. Negative 4 times 5 times negative 15. Let's see what we get. That's 300. Positive. Okay, so no, we don't have any imaginary numbers here. We may have some complex solutions. Let's see, is 316 a perfect square? Nope, definitely not. All right, just double check to make sure I plug this in all right. 16. Yep, all right, we are good to go. Let's proceed. X equals positive 4 plus or minus the root of 316 all over 10. Now, I'm going to try to simplify that root 316. Let's see here, 316. Let's just try dividing by 16. Let's see if that works. That does not. Let's lower our perfect squares. Let's try 9. That does not work. 316 divided by 4, question mark? Yes, all right. So this breaks into the root of 4 times the root of 79. Okay, so 4 plus or minus. On the outside is the root of 4. On the inside is the remaining leftovers, all over 10. So yes, it's a good thing we use the quadratic formula for this one because this would have been, I believe, impossible to factor. We simplify because, like I mentioned yesterday, picture this as 4 plus or minus 2x over 10. You need to know that the 4, the 2, and the 10 can all be divided by 2 and reduced. This is the same thing, just with a square root. So divide it all by 2. And we get our answer. Now, this is one that we cannot put into points like the first one. So 2 plus or minus 1 root 79 all over 5. Yeah, no putting those into points. I don't want you estimating those because that's just more work that you don't need to do. Leave it as a complex fraction. Okay, and that's your bell work, a warm-up on the quadratic formula and solving by factoring. So let's move on. The goal of today's lesson, linear quadratic systems. Find the intersection or intersections of linear and quadratic systems. Or basically, we're going to graph, well, not graph, we're going to solve and see where some lines and parabolas intersect. We could have 2 solutions, we could have 1 solution or no solutions. In this section, we will not have imaginary numbers because if these 2 things do not intersect, these are things that are on the real plane. Remember, your complex plane was a place where you plotted imaginary complex numbers. This is not one of those cases. So if you happen to have a problem that you solve with the quadratic formula, let's just say, for instance, you've got x equals 4 plus or minus something, something, and this comes out to be negative. You have to know that because we are seeing when 2 graphs intersect, this is not possible in this section. The previous sections were just hypothetical problems. These are problems where we are saying, do these 2 graphs intersect? And no, it does not. So, let's get going with this. This is how these problems will be presented to you. Solve each system by substitution. I label my graphs in different colors so you can see how I set this up. The first one, y equals 3x squared plus 3x minus 5. I know that's my parabola because it has an x squared. The second one, 2x minus y equals 3. That is my line because it has a plain old x. And no, you don't have to convert the second one into y equals mx plus b. Substitution means you're taking something and plugging it into something else. Well, in the first graph, it says y is equal to this. So we're going to take that and swap it out for the y in the second problem. As you see down here, I labeled my first one in sort of a purple color, and you'll see it has taken the place of y in my second problem. Now I'm going to distribute that negative. And I'm going to combine like terms, pull that 3 over, because if we're going to use the quadratic formula or regular factoring to solve for this, everything has to be on one side. All right, so let's see here. Negative 3x squared. Ooh, I don't like that negative. We'll see if we can do something about that. We've got negative 3x and positive 2x, so that's 2x minus 3x is minus 1x. We have plus 5, but it's equal to a negative 3. So this is going to be where you need to do a couple steps at a time. So I know that I'm going to have to subtract 3 from both sides. Let me space out my next line a little bit. So negative 3x squared minus 1x plus 2 equals 0. Now, I do not like having a negative x squared. So what I'm going to do is take this entire problem and put everything on the other side. You can do that whenever you want to. This way, my x squared will be positive because I want to solve this problem with factoring. It's quite a small problem. No need to use the quadratic formula. You can if you want to. So 3x squared plus x minus 2 equals 0. And it looks like I'm going to have to space out my next problem. All right. So again, all I did was take all 3 of these, boot them over to the other side, which means I added 3x squared, subtracted x, added x, and subtracted 2. Now, let's get going on the factoring. 3 times 2. What multiplies to get 6? Negative 6, excuse me, and adds to get 1. Well, there are really only a couple things we can choose from. That's going to be 2 times 3. 2 would have to be negative, 3 would have to be positive. Let's move forward with our slide and divide. X minus 2, x plus 3. Divide by our lead coefficient of 3. Okay. We got 3x minus 2. That 3 is weird looking. There we go. X plus 1 equals 0. This is looking a little squished. I'll be sure to spread this out a bit when I post my notes. So we have x equals, we're going to take this one, set it equal to 0. We would add 2, divide by 3. And the second one would be negative 1. But of course, we want to represent these as points. So let's see here. I'm going to choose the second one because that has the least amount of, well, it has no x squareds in it. That would be kind of a pain. All right. So I'm going to take these two x values, plug them back into the original equation because we are trying to find the points at which these intersect. So let's see here. If I take my 2/3 and plug it back into here, yes, I'm going to have to deal with some fractions, but that is okay. So 2 times 2/3 minus y equals 3. 2 times 2/3 is 4/3 minus y equals 3. We're going to subtract that 4/3 to the other side. Let's see here. Handy dandy calculator, will you help me out? 4/3, and we are subtracting that away from 3. On some scientific calculators, you should be able to convert to a fraction. Okay, so you have minus 4/3. Let me rewrite that slightly. 3 over 1 becomes 9 over 3. Negative y is equal to 5/3. Of course, we don't want negative y. We want regular y, excuse me, so that's negative 5/3. Our first answer is 2/3, negative 5/3. You most likely won't see fractions too often, but don't fret. Just convert whatever you're subtracting to the same base, and it will go smoothly. Second one, 2 times negative 1 minus y equals 3. This will work out a little nicer. Negative 2 minus y equals 3. So when I add that 2 over, I will get 5. Y equals negative 5. My second answer, negative 1, negative 5. Okay. So the one difference between these problems and the previous ones we've been doing is plug them back into one of the two equations. I always recommend the linear equation because that way you don't have to square anything. Got to get a square fraction and combine it with another one with a different base. Yeesh. All right. Let me do a couple more examples for you, and then let's just get rolling. Here we go. Solve each system by substitution. We're going to do the same thing as last problem. I'm going to plug equation 1 into equation 2 because that works nicer for this one. So again, this is what's equal to y. I'm plugging it into this y down here. 2x minus 2x squared minus 6x minus 8 equals 16. Don't forget to fill in the rest of the problem. That's a common mistake I see sometimes. Okay, 2x minus. Always remember to distribute your negative sign. Okay. I'm going to do what I did last time, combine like terms, and since the x squared is negative, I'm going to move this over to the other side. Okay, so let's see. 2x and 6x is 8x. Now I have positive 8, but I am going to be subtracting 16 from both sides. Okay. Alright, and then same thing from last time. Okay, so again, I don't like having a negative x squared, so I just moved everything to the other side of the equal sign and then switched it back. So technically, at first, it looked like this. All I did was just put the 0 over here. Everything's still equal to 0. You can manipulate equations however you want to. All right, now this one I could do factoring. I think I might because this has a GCF. So when I pull it out, 2x squared minus 4x plus 4, x minus 2, x minus 2 equals 0. You might be wondering, how did I do that real quick? The only thing that can multiply to get 4 and add to get negative 4 is 2 times 2 of the negative variety. So this is an example of when we have a parabola intersected by a line at only one point. And that point, well, the x value at least, is negative 2. So x equals 2. Of course, we are not done here. We need to plug this back into one of the first two problems. Again, I always recommend a linear problem. It'll work out a lot nicer for you. So plug it back in. 2 times 2 minus y equals 16. 4 minus y equals 16. Subtract the 4. Negative y equals 12. So y equals negative 12, giving us our solution of 2, negative 12. All right. So the next part of the video will be a try it. This is where I'll say, pause the video, give this problem a shot. There's a second one down here if you'd like to give that a shot. If you feel comfortable, you do you. But yes, at this point, go ahead and pause the video, try this problem, and then unpause, and you'll see my solutions will be here for you. Okay, this is back after you unpause the video. Let's see what we got. This one I'll do mostly without narration. Okay. This one also has a GCF, so I will pull that out. And that leaves us a fairly simple problem that I'm going to factor. 3x plus 2, x minus 1 equals 0. What multiplies to get you negative 2, but adds to get you 1? That is positive 2 and negative 1. So x equals negative 2 and x equals 1. But of course, we need to find out what the y value of these coordinates is going to be. So I'm going to plug them back into 4x minus y. So 4 times negative 2 minus y equals 2. Okay, so we have negative 10 for 2, and right next to that, I'm going to write the other one. And then we have 2 for this value. All right, and that's all there is to it. If you'd like to do this other problem down here, I will be proceeding with that one as well in the video, but if you'd like to, just hop on a Canvas, and these are your homework problems. My honors students, you have an extra problem. This is determine how many solutions there are. Now with this one, you don't have to solve it fully like I did here. You can just work your way through the problem, and when you reach the point when you choose to either factor or use the quadratic formula, you can just tell me how many solutions there actually are. You can just get to this part here and say, oh, okay, I see there are 2 solutions. All right. So if you've chosen to continue with this video, I will now do this problem here. More practice never hurts. These lessons are longer than I thought, and then of course I remember, I'm trying to keep this the same as in person. So normally my lessons take up about a third to half of the class. I don't like taking up too much time because I like making sure y'all can practice. Okay, equation 2 and equation 1. Now, the past couple ones we plugged 1 into 2. This one it looks easier to plug 2 into 1 because this one's already solved for y. We're going to plug it in right there. So negative 3x plus 1 Okay, let's move everything to one side. I'm going to move them to the right side, so my 4x squared would be positive. I'm going to add 3x squared to both sides, subtract 1, and add 4x squared to move these all over. That's going to be plus 6x plus 3. All right. Okay, now you can use the quadratic formula or you can factor. You will get the same answer either way. With this one, it's not that large of a problem. For this one, it's not that large of a problem. This is where I'd recommend factoring. If you use the quadratic formula, you'll still get the correct answer, but it might take you more time than factoring one. So what multiplies to get us 4 times 3, which is 12? But adds to get us 6. 1 times 12, 2 and 6, 3 and 4. You know, this is one we actually might want to use the quadratic formula for, because it doesn't look like we can find any factors that are going to give us 6. So we're going to have a weird answer for this one. But that's okay. Let's see what happens. Now, if it's not factorable, that also might mean that these two don't intersect. Food for thought. So A, B, and C. So x equals negative b plus or minus the root. Okay. Okay. X equals negative 6 plus or minus the root. Now, take a look at this. Inside the root, we have 36 minus 4 times 4 is 16. 16 times 3 is 48. I know for a fact this is going to be a problem where these do not intersect because we have a negative underneath the square root. Like I said at the start of the section, this is where you have to know that you stop solving. There are no real solutions for this, and since we're looking for specific points where they intersect, this is not the section where we come through and solve for imaginary solutions. So this is where you know to say no solutions. Because the discriminant, that number inside the square root, is negative. This parabola and line do not intersect. Alrighty, and that is officially the end of my lesson. Here are your 3 problems for Algebra 2 Regular and 4 problems for Algebra 2 Honors. Let me know if you have any questions.